Good morning. Thank you very much for having us here. I'm Tom Chung, principal with Leers Weinzapfel Associates, and we're continuing on the theme of education, looking at higher education, and we're going to jump scale a little bit into whole buildings and new buildings. So before we begin, just a quick sentence or two about our firm. So we're a Boston-based design firm, about 30 people. We've been in practice over 30 years. And it's really in the last 5-6 years that we've gotten into the world of mass timber. And it's been a roller coaster ride, but one that we've enjoyed. And I'm happy to share our learning experience with you guys today. Just to say that we've been honored with the AIA Firm Award, which was really a great honor for us. And that's really a testament to our collaborators, our collaboration with our engineers and consultants, but primarily our collaboration with our clients. Because as we all know, as architects, you can't have good projects without good clients, so that's fundamental. So the title of the presentation is called Live Learn, the Versatility of Mass Timber in Higher Education. And we've had the good fortune to work on two basic typologies that are in higher education in universities. The learning typology, the classroom, you find that in all types of departments and all types of shapes and forms. And the living typology, the student housing at universities. So we're going to look at mass timber through the lens of these two basic building types and how they differ and how they're similar. So before I start, can I just get a sense of how many of you guys are architects and engineers? Raise your hand, please. Okay. And contractors? And people affiliated with universities. Great, so we've got a good crowd, and I think a good diverse crowd, and then we'll address points that I think would be of interest to each and every one of you guys. So this presentation, when I gave this last time, I had 45 minutes, so I have 25 minutes today, already into like 3 minutes of that, so we'll try to go through this as quickly as possible. So we're going to structure this into what, how, and why. First, in terms of the what, we're going to give a brief introduction about the two projects. And how, in terms of how do you apply mass timber across those building types in terms of understanding of program and structure, because that's fundamental to the design process, and costs, code implications, because of where we are in the regulations, that's a challenge that we're all facing code regulations right now as it stands. And then constructability, how do you realize your design and your vision into built buildings? And then we're going to end with why. At the end of the day, why are we doing all of this? What really this, as architects, designers, people in this industry, what is really the big picture? And we'll talk about both the quantitative and qualitative aspects of mass timber, the metrics behind all the benefits sustainability-wise, and really the experiential benefit of what a mass timber building and what potential that has. So before I begin, I just want to give a shout out and credit to the team of collaborators at the University of Massachusetts. We really couldn't have done this project in mass timber without the advocacy of two people, Peggy Clouston and Alex Schreier, who were the faculty members at the Building Construction Technology Department. So their leadership was really critical from day one. And then the team of collaborators, there are many, but in particular, Equilibrium Consulting, who were the structural design engineers, and Simpson, Gumberson, Hager, who were the structural engineers of record. For the University of Arkansas projects, likewise, you need a driving force. Dean Peter McGeeth with Fay Jones School of Architecture was really the one who brought the vision of doing the project in mass timber. And again, at the team of collaborators, the same structural engineer we had Equilibrium from Vancouver, and then it was a design collective. So we led the design and the mass timber expertise. But we collaborated with Modus Studio, a great design firm. We collaborated with them in every single aspect of the design. And then also Mackie Mitchell, who are a housing specialist out of St. Louis. So just to set up the UMass Amherst project, this is a home of the design building for the departments of architecture, landscape architecture, and building construction technology. And here's the view of the campus. What really set this project in motion was that these three departments were on separate buildings across campus. And so there was really no opportunity for them to collaborate. And the university decided to build a new building to bring them all together so that they could collaborate and advance this discipline. So given that, the idea was the building was very simple. We started out with a courtyard typology, given the common center that was critical to the the mission of the program, but we also wanted this building not to be so internal, but to engage the university. So we opened it up with two very simple moves, looking at the geometry of the site. We opened it up in plan, and then looking at the scale relative to either side of the building, we lifted up one end so that the central interior space could be viewed and accessible to the campus as a whole. So that's the sectional perspective of how that all comes together. The central courtyard space is actually divided into two, an interior two-story central commons and a landscape garden above that. And those two spaces center all the additional programs around the building. So the studios, faculty offices, classrooms, seminar rooms, all of that look into the central space. Kind of jumping ship now and talking a little bit about the University of Arkansas Student Housing Project. This was a new housing complex for primarily sophomore students at the southern end of the campus. And so the context was essentially a parking lot, a vast empty parking lot in the middle, adjacent to the athletic building. So we had the issues of scale, being far away of center of campus. So the strategy really was to create not just a building, but a complex, a series of buildings intertwined with the landscape, so that it created really a destination and a feature to draw students from the center of campus to the southern edge of this campus here. So we worked closely with Olin Partnership for landscape architecture, integrating the building and landscape. One of the early decisions we made was in terms of the typology of the rooms. And we made a decision early on to make the upper levels as compact as possible to fit as many bedrooms as that were needed in the program, but to also create nodes of interaction at the upper level. So looking at a typical floor, you can see that the nodes are the central places of gathering, both public nodes at the center of the building, and at the ends, more quieter study nodes. And then we take the rest of the building and make it as compact as possible and efficient as possible. And in contrast to that, the ground floor was very fluid. It was really for a live-learn community, not just for the students in this complex, but also for the university as a whole. So it included a lot of maker spaces, different art studios, commons, kitchens, community kitchens, all of these things that would create a sense of community, all intertwined with the landscape. So this is how all of that kind of is shaped around this southern edge of the campus, surrounded by really big athletic structures. So going into the first topic of program and structure, going back to the design building at UMass Amherst, this is the typical upper floor plan, and you can see that the plan at every level has both student spaces and faculty spaces, so large open spaces for studios on the north and to the west, and then smaller faculty offices surrounding the other two wings of the building, centered around the courtyard. This was the structural framing of the building at the end of design development. And if you look at it carefully, it's not a timber frame, it's a steel frame. So we started this project as a steel building. So although there was an aspiration for the project to be in mass timber, this was the first of its kind in the northeastern United States. So there was a lot of hesitancy in terms of cost, the risks, all of these factors that we deal with as architects in a building of this complexity. And so we had early on looked at mass timber glulam and CLT structure at the schematic design because we knew that there might be a chance that this would go to mass timber. So very important things like column grid spacing, the span of beams, those things we looked early on and said, since there's a chance that this might go to a wood structure, let's make sure that those basic fundamental decisions that we need to make will be flexible enough should the directive change. And sure enough, it did at the end of design development when there was additional funding secured by the state legislature as a sustainability project, as a showcase for this building. So then we went full board with a timber structure, and this is that same framing in timber, and I'll just go back and forth. You can see there, again, as you know, the steel structure is very, very formulaic in a sense that you've got beams and you have a typical 12-foot metal deck span that's very efficient, and so you've got beams at every 12 feet here. With cross-laminated timber and its two-way spanning strategies, one of the pleasant things we found out was that we could eliminate about half the beams. And particularly in areas like this where we don't have transfer beams, you just have one-way beams and the CLT panels span. So that is really great for allowing a lot more space up in the ceiling cavity for mechanical coordination for all the infrastructure that you need. So taking a step back and looking at the overall structure, foundation is out of concrete. You have the superstructure primarily out of a glulam post and beam, then cross-laminated timber floor panels and roof panels. We had a composite structure because of the beams, and we'll get into that a little bit more later. The central space was then an opportunity for a dynamic feature, which was the zipper truss, which I'll get into a little bit later as well. And then we collectively, as the design team and the client team, made the decision to clad this not in wood, but out of aluminum panels. So it's a copper anodized aluminum panels, and that was purely for cost purposes and the maintenance purposes dictated really by the university. And I just go back here and I say, as an architect speaking at a timber conference, my responsibility is to use each material to the best, the way it makes sense. So it makes sense for foundations to be in concrete. You want to keep the wood out of moisture or in contact with water. And for things like cantilevers and long spans, it makes sense to use steel because those materials do that best. But there is a sweet spot and a use of timber for majority of the structures of this size of mid-rises from 6 stories downwards, where it makes a lot of sense, and we'll go into those details. So this is a model that we made showing how all of that comes together, integration of the wood structure with the rest of the architecture. And in terms of the process of doing that, we relied a lot on digital modeling, and that's critical that you design in 3-dimensional software, whether it's Revit, SketchUp, Rhinoceros, whatever it may be. It's important to do that because once this is handed over to the supplier, they're modeling it. So the more you have a good sense 3-dimensionally, that'll just help you in the process. Same model looking at it from below, and you can see where the steel beams are, where the cantilevers are necessary. At the University of Arkansas, it was a very different process. There was real interest to look at this in mass timber, and they were going to do this as long as it met the budget of the project. But again, it was new in Arkansas as well, and there were also lots of fears and hesitancy. So we carried this as both a timber building and a steel building from concept design through schematic design, and we made a decision to go with one or the other at the point of start of design development. So as housing goes, it's critical because everything is based on the module of the rooms because there's so many of them. This is a 700-bed, so 350-room complex. And we looked at various modules, and we settled on this module in terms of pair of rooms with 2 students per room for sophomore housing. And we looked at different grids, but we settled on a grid of 12 feet and doubled that 24 feet on center for the structural grid. And that made a lot of sense because when we did this, we were looking at a lot of suppliers, and we were trying to maximize the capacity of these suppliers in terms of what they were able to make, because each supplier will have a different press, will have different maximum size of CLT panel dimensions. So you want to make sure in a public project like this, where you don't have a supplier at the beginning, but it's an open bid process, that you maximize your competition. So this was a strategy that we took. And then you multiply that into a section of the building, and at the concept stage, we looked at it this way, looking at it in steel structure, both in steel frame with steel bracing for the cores, concrete cores, and then wood structure, glulam post and beam with CLT floor panels, but with steel frame for cores, concrete for cores, and then everything, the CLT for cores as well. The next stage, once we made that decision to stay and go with mass timber, we developed the rest of the project working in Revit. So this is a structural model of that. And you can see the overall structure, and the decision here was made to go with a cast-in-place concrete for the vertical cores. And you can see from the underside, given the concept of the building of landscape intertwining with the building, we had to have large openings at the ground level for the landscape to flow through the complex, and hence there was a lot of steel beams and cantilevers to create those openings as well. So code implications, but before I get into that, just why this is important is that the parameters of two projects were different. And the UMass building, we started out really as a steel building and did not change until later on. At Arkansas, we started out intentionally as a timber building and looking at the module of cross-laminated timber and making that as efficient as possible. So the two projects, the housing project is about double the size and double the cost, but the timber package in terms of the material, the supply, and the installation was about the same. So now they're not apples to apples in terms of all the features. So I would say, in a good estimate, by having a rigorous look at the modularity and the system of CLT panels, that could represent easily somewhere between 25 to 30% savings in the structure. And this is big, particularly as budget issues that everybody's asking how much our timber building is going to cost. And the answer is, well, it depends. It depends on the type of project. It depends on what you want, what type of features you want, whether it's a public process, private process. All of these things come into play. The other challenge, code implications. At the design building, when we started the process 6 years ago, really CLT was not even in the building code. So really had to do this as an alternative structural approach through a variance process. We had CLT floors, panels for roof and floors, and shear walls as well. We knew that in 2015, IBC CLT was coming in, but that didn't help us at that time here for us. We relied on guidelines for PRG 320, NDS, CLT handbook. So really all this was really gathering the research that was what was done before. We knew that in Europe, this has been going on for 20 years, and in Canada, 15 years. So although it was new to the United States, this was not something that was new to the world. And so we conveyed that. We had early meetings from day one with the code officials, with the AHJs, authorities having jurisdiction. And I would say that is probably the number one most important thing. Regardless of the region you're in, bring them in very early and have them be part of the process so that you build trust and you show why you're doing this, the importance of building in mass timber. So at the end of the day, we had a very progressive building inspector who was all on board. But he did not want to take the responsibility of giving an approval. So we went through a formal variance process, but the key was that he wrote a letter in support of us for the variance. So after that really was just really easy process. It was just a formality of handing in paperwork to do that. The one thing that was another variance was that because this was under type 4, there's a limit of you can't have concealed spaces. So that was a variance to limit, and we needed about 20% of the ceiling spaces to be concealed. And so that was a variance that was accepted as well. So at Arkansas, we had a very different process. So on day one, again, we invited all the fire marshals, the code officials, and on day one they said this: in Arkansas, 2012 Arkansas Fire Prevention Code, this is our Bible. So while we appreciate what you're trying to do, what the university is trying to do, we are on board with all of that, but we're not going to give you any variance. Okay, so very different than the UMass building. So we took a look at, okay, under the current code, how can we do this? Now this was in 2015, so the IBC was in the code. Problem was Arkansas had not accepted it yet. So we looked at different building construction types, and as we know, right now you can do CLT in either under type 3, type 4, or type 5. And the work that we heard yesterday at the keynote from Susan and others was the incredible work they're working to expand the type 4 construction. So here, we compared it, we showed them what the building might be in a steel building, a type 2A, and then of those three choices that we had, we selected a type 3 as an approach, as a way to do this prescriptively under code without any variances required. So essentially, type 3 allows you to be any type of structure, whether it's combustible, non-combustible. The big catch here was the limit of height and the area, and we knew that our size was all within those limits. And then also just the fact that the exterior assembly had to be non-combustible or fire-treated. So we went through early diagrams very early on, showing the fire marshals how we intended to detail these things so that the exterior assembly was separate from the combustible structure. We wanted to expose as much wood as possible, the underside of cross-laminated timber panels, the columns in the spaces. So all of that then was prescriptively done, looking at code calculations for wood and how it burns. We know how that it burns, and we know how, charring effects. All of that is in the code right now, so that can be relied on too, so that you can expose the wood and not cover it up. The third topic of constructability. So the design building was finished last year. Construction has started on our Arkansas project, so we're going to talk to you primarily through the design building. So this was probably about 70% done in terms of the structural framing, and here's a close-up of that in terms of how the different elements come together. And what was really neat is that with the advancement in digital technologies, which allows these timber structures to do what steel and concrete structures can do, is that some of these details are so, I found it very neat. In a traditional heavy timber building, you would have a detail like this where you'd have an exposed steel connector. Well, where's the connection here between the column and the beam? Well, it's there, it's just all hidden. So and forget about even like welding or bolting, you just slide this, the beam just slides on, right? So the net effect of all of this is that it is a super fast construction. The overall construction of this was about 18 months, and that was from starting the site excavation to the move-in. So that wasn't any different in this case from a traditional steel building or a concrete building in Boston area. But what was significant was that the overall, just the framing of the post and beam and the CLT panels, that was about 2 months. So that went super fast. It was the rest of the trays and the building envelope enclosure, those things which still had to be accounted for. So a lesson learned is that, yes, the structure is so fast, but you have to then coordinate all the other trays. And if you could prefabricate as much of that possible, then this is where really the savings comes in. Here's just a view of the bracing coming together. Again, just a simple pin connection. Cross-laminated timber roof panels being installed. The other benefit of this is that it takes a very small crew. So there was only a crew of about 5 to 7 people during the whole time for the structural framing, with 1 crane and a couple of cherry pickers. So again, a very minimal crew on the site, very small time on the site in terms of the framing, and also a very quiet construction. There's not a lot of heavy banging or welding of things, and it's super, super quiet. So in universities where there's residences nearby, in tight urban areas, this is another advantage of mass timber construction. So here's a cross-laminated timber panel being lifted into place, 2 guys waiting to receive that and then screw that into place. And here we use the composite technology where we had concrete on top of the CLT panels with a metal connector so that they could work in composite action together. This was particularly important because this technology was researched and developed at the university, so it was a great marketing story for the university here. So here's the panels in place with the perforated metal connectors sticking out. Here's the insulation panels for acoustics, and then after the concrete's been poured and polished. As I mentioned before, we wanted to demonstrate the limits of cross-laminated timber. So all the lateral forces, the shear walls, are all cross-laminated timber in this case. Here's the elevator shaft, the inside of it, exit stair, egress stairways. And we wanted to, again, expose as much timber as possible. And again, we had a very progressive, willing code official who allowed this to happen, given the common sense that fires don't really start in exit enclosures, right? That's where you go to escape fires, and there's sprinklers there. So we put drywall on the outside of the stair enclosure, and we could leave the stair exposed as it was. So that was really great. So with all those details of design, construction, again, as I end this presentation, let's take a step back. What's the big story here? Why are we doing this? And at today's keynote, Bill Browning was talking a lot about this in terms of the biophilia, the benefits of wood. We know that it's renewable. I'll just go through this quickly because you've heard this morning. The clear-cut forest grows back. This is 5 years afterwards. It's already growing back. In 25 years, it'll be what it was before. And then there's a lot of talk about carbon sequestration. And when I first heard that term, I was like, what is that? Is this some really super high scientific term? And the best way I understand it for myself is put it in terms of what a kindergartner would know. We all learned in kindergarten that trees are good for you, right? Why? Because we breathe out carbon dioxide, trees take that in and make oxygen, right? We all know that. And so where does all that carbon go? Well, it goes into growing the trees, right? Majority of that goes into that. So this is why carbon sequestration, holding of carbon within the trees, and using that for the life of the building is great, because if you don't develop forests and it gets dense, then you have overpopulation of forests and wildfires, as we all know. The other aspect of it is embodied energy in terms of the total energy from extraction to disposal. It's far less than steel or concrete. And essentially, it makes sense because what you're essentially doing with these mass timber products, you're just debarking the trees. There's not a lot of high energy process involved here. And so in terms of the quantitative metrics, this building, the amount of volume of wood could have been produced in US and Canadian forest in 6 minutes. So that's pretty incredible. And all the carbon that's sequestered in this building, the carbon impact is equivalent to about 512 cars off the road per year, or energy to operate a home for 228 years. So that's pretty significant. But at the end of the day, as architects, as designers, we want spaces that are exciting, pleasant for people to work in, especially at school where education is so fundamental. So we wanted to make sure that this building, although it was clad in a metal, was communicated as a timber building from the outset. So strategies of big openings to expose the timber structure while protecting it from the element was critical. The cladding strategy, although it was metal, using a tone that was brown, kind of bark-like to give that sense, where you have the darker tone of the outside, and as you go in, you have the lighter tone of the wood. That was all very intentional. And then we really wanted to press the dynamic quality, what you can do with timber structures in the advancements of engineering, where structure architecture and architecture become one. The central space, which really brought everybody together so that all the spaces opened up onto it, creating a dynamic exchange of ideas and collaboration, and even within that space, creating intimate spaces for students to quietly study, to overlook at the zipper trusses, the central areas. And then above in the commons, having a courtyard, an outdoor space, going back to nature, bringing in plants and landscape. In some ways, making a full circle. It's a wood structure building, but there's a courtyard that's planted and in which wood grows. We thought that was a good way to combine both architecture and landscape architecture. So just some more images of that. And then the central major studio spaces, not just the lightness and the warmth and the touch of wood, but the smell of wood. Students said, wow, this smells so nice, like a fine pine forest. And just that level of just human comfort in these spaces, I think was very important, especially in studios where students just work for 24 hours, as many of you guys know. So especially in those places, it's very important. And we wanted to make sure that we expose the wood as much as possible in offices, conference rooms, in laboratories, showing the strength of wood to hold cranes and all of those things. And then going back to really the essence of what we're trying to do, create beautiful spaces with beautiful details. And that's the same hope here in Arkansas as construction starts. Just some images, very simple dorm rooms for sophomore students. The university really wants them out of their rooms and in the common spaces. So we put a lot of effort on the amenities, the feature of these common areas, with all, again, exposing wood and the structure. And I'm just gonna play a quick 1-minute video to end. And this just shows the integration and the concept of the building and landscape being one, in which the students are encouraged to go out of their rooms and really become part of the community of the larger university. We found, incidentally, that the hammocking was really popular at the University of Arkansas, so we used the opportunities for structural columns to provide those places for hammocking. So what this, I think, shows that is within current code. If you're not a high-rise, then you can, even in an environment where you have very conservative code officials, per the prescriptive letter of the code, you can get this done. And you don't have to cover up the wood. You could expose it and take all the benefits of the experiential quality and the intangible benefits of wood. Okay. So just ending on a last note, I think this is what the conference is about. The design, building, and construction featured our design building last year as a game changer, and I think that's the story here for so many ways, environmentally, experientially, not just in the forest industry, but also in terms of how this helps our rural communities, the social aspects of it, in many ways. I think this is really exciting and really happy to be part of this conversation. So thank you very much.